Next paper is a different domain, railway warning and control systems, and its authors are KHL Chathurange, RMDPK Rathnayaka, and TSN Wimalasiri. The presenter is TSN Wimalasiri. Ms. Sachini Wimalasiri is a lecturer on assignment basis at Department of Electrical and Information Engineering, Faculty of Engineering, University of Ruhuna. May I invite Wimalasiri to start the presentation.
Good morning, all of you. I'm Sachini Wimalasiri, and I'm here to share my undergraduate project ideas and with you, that is railway warning and control systems. In here, we have in this presentation, I will describe about the introduction to problem, and also what are the implementations that we have done, and also that further implementation that can be done to this model concept. First of all, let me say why we go to implement this project. You know, oftenly we hear about accidents at railway crossings. These accidents are fatal. These accidents cause fatal deaths, and also they are, you can see on these figures, they are so much destructive. So, what is the reason for all of these kind of accidents? The main reason for these kind of accidents are unguarded railway crossings. You can see people travel across the crossings without considering about the train. So, if there's a barrier or there's a guarded railway crossing, they won't cross across these railway crossings. So, we have, according to Railway Department statistics, there can be found about over 1,000 railway crossings in all around the country, and over 600 do not have gates. They are death traps, and you want to know the electric rail gate will cost nearly about 45 lakhs. So, in our project, we done a preliminary research in the region from Galle to Hikkaduwa. At there, we have found out about 50 crossings, and among them, 10 crossings have full performed railway warning system, but about 88 crossings, there are no warning system in the railway crossing. So, our aim is to introduce a cost-effective, smart railway warning and control system. The main aim is to reduce the cost, because about 45 lakhs you have to spend on a railway crossing. But it's so much costly for railway department, so our effort is to find out a method in cost-effective way. And also we are going to power these nodes with eco-friendly methods. In our design, we have used 3 nodes, for 2 sensor nodes beside in the either side of the railway crossing, and a main control unit is located in the railway crossing. And these sensor nodes are kept about 5 meters apart from the railway crossing. And these are the main control node and sensor node. In main control node, we have used siren alarms and warning lights to warn the public. And in sensor node, we have used train detection sensors and also a microphone to detect the train. We use these sensor nodes to detect, the main purpose of this sensor node is to detect the train. Here we have used 2 ultrasonic sensors for one sensor node, and these 2 ultrasonic sensors are kept in 2 levels in the sensor node. And then we use before we move on to a microphone, we have used vibration sensors, but we have to find out a proper place to locate vibration sensors. We have done a research before that to find out a proper place to locate the vibration sensor in the railway track, but always we have to find a middle of a railway track to locate this, but we cannot always find that kind of place, so we have moved on to this microphone, because when you know that when a train is approaching, there's a loud sound from the train, and this first figure shows the sound levels of approaching train, and you can see the amplitudes of the train is very much higher when we consider the other amplitudes of the this graph. And we have used this microphone to get the detect the train. So with the use of 2 ultrasonic sensors and 1 microphone, we get the that train is approaching signal, and we transmit that into the control node. In the control node, we use NRF24L01 module to transmit wireless module to transmit the signal of that train is coming. And in the control node also, we have used warning lights and siren alarms to warn the public. In here also we have used 2 ultrasonic sensors, because we need to switch off these lights and siren alarms after the train is passed away from this crossing. And we give power to this two modules using solar panels. So we use a battery charger unit, and we use a solar module to give power the one control unit and 2 sensor nodes. And as a conclusion, I would like to say we have successfully implemented this one as a model, and also we are further, our next step was to introduce a servo motor kit at the railway crossing to operate the gates, and also we can use this one to network the all railway transport system. And so thank you.
Thank you very much for the presentation. Again, just remind that please make sure to note down your queries for each paper. We will take them up at the last, after all the papers are presented. Let's give a hand to the presenter.